KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.com.
Good morning students. In these sessions we are going to discuss another important bond, coordinate covalent bond. But before we are going to discuss coordinate covalent bond, some important terms are discussed right now. Already in my last class, single covalent bond is completed, double covalent bond is also completed, triple covalent bond is also completed. But in the formation of covalent bond, already I said, in the formation of covalent bond, initially the atoms are involved in the overlapping. So you know that very well how many types of overlappings are there: SS overlap and SP overlap and PP overlap. So now here important point is, in between of any two atom only one bond is there, that is a single bond, single covalent bond. That single covalent bond is nothing but sigma bond. And if any two atoms form double bond, one sigma bond, one pi bond. If any two atoms involved in the three bonds, three covalent bonds, one is the sigma bond, remaining two bonds are the pi bonds. Okay, now today discuss sigma bond definition and pi bond definition, how to form sigma bond and how to form pi bond. Now basically see here, sigma bond, end-on end overlapping of orbital, end-on end overlapping to form sigma bond. Here orbitals nana, end-on end overlapping of orbital to form the sigma bond. It is represented like these symbols. This is a sigma bond symbol. Okay, if two orbitals approaching to each other, so the end-on end overlapping in between of the two orbital, end-on end overlapping, hence to form one bond, single bond. That single bond is a sigma bond. Basically, my dear student, sigma bond is an independent bond. So for example, whenever two atoms are approaching to each other, after completions of the overlapping, one sigma bond is formed. So that's why it is independent bond. First formed bond is the sigma bond. That's why it is an independent bond and very strong bond. Sigma bond is a very, very strong bond comparing to the pi bond, which is a strong bond. Sigma bond is a strong bond. Now see here example, sigma bonds is nothing but end-on end overlapping of the orbital to form sigma bond. It is represented by the symbol like this one. Now see here example H2 HCl. In between of the H2 and HCl, single bonds are there. In a hydrogen molecule, single bond is there. HCl also single bond is there. That single bond is nothing but sigma bond. Now see here example, hydrogen, one more hydrogen to form H, single bond H. Here single bond is considered as a sigma bond. So in the hydrogen, first hydrogen electronic configuration 1s1 and second hydrogen electronic configuration 1s1. So this is the s orbital structure, one electron, and this is one first hydrogen atom. This is a second hydrogen atom, one electron. Now these two orbital, this is s orbital, this is also s orbital. These two s orbital approaching to each other, what happened? This orbital end and this orbital end overlapping. So end-on end overlapping in between of the two orbitals, end-on end overlapping, hence this kind of the bond is formed. This is a sigma bond. Sigma bond is nothing but single bond. Single bond is present in any molecule, that is a sigma bond, and it is a very strong bond. So very strong bond comparing to the pi bond, and it is an independent bond also. It is also independent bond. So this is a sigma bond. Once again, what is a sigma bond, my dear students? End on end overlapping of the orbital to form sigma bond. Sigma bond is a very strong bond. It is an independent bond. If any one of the molecule has only single bond, that is a sigma bond. That is a sigma bond. First formed bond is also sigma bond. So if you, for example, two bonds are there, sigma bond and pi bond. First formed bond is the sigma bond. It's clear, Nana? Now, second one is the pi bond. This is too important, Nana. Sigma bond, pi bond. Pi bond na side on side wave overlapping, orbital sides, not a end on end. Side on side wave overlapping of orbital to form pi bond. It's represented pi symbol, you know, mathematics pi symbol, like this one. But this type of the bond, how to form? Side on side overlapping. For example, two orbital approaching to each other, two orbitals are approaching to each other. One orbital side, another orbital side involved in the overlapping, hence one bond is formed. That bonds is nothing but the pi bond. Now for example, here pi bond category point of view, some examples are there. See here, oxygen molecule, carbon dioxide molecule. You are observing pi bond in the molecular of oxygen structure. So now see here, O2. O2 na, O plus O is gives rise to O2. So in between of the one oxygen to another oxygen, double bonds is there. Double bonds means one sigma bond, one pi bond. Now see here, structure point of view. Oxygen atomic number 8, 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. Now in this 2p4, s orbital satisfy with 2 electron. Even second 2s orbital also satisfy with 2 electron. But the 2p4, there are 4 electrons are there, but one pair of electron, remaining 2 unpaired of electron. So py orbital, one unpaired electron is there. pz orbital also one unpaired electrons is there. This py orbital, pz orbital involved in the overlapping, then to form double bond. Now see here, I can already draw some structures here. py. So you know p orbital, py, this is the py structure, py orbital. This is oxygen structure nana. One oxygen low, this picture is represented py orbital and pz orbital. So y axis, z axis. In the y axis p orbital is there, you know that dumbbell shape. So this is the py. So why I mentioned here py, pz only, not px, you know that very well. Unpaired electrons only involved in the covalent bond. That's why in oxygen atom, each oxygen atom, unpaired electrons are present in the py and pz. That's why I draw here only py and pz. This is a px completely paired. So py and pz. So this is the two orbital in one oxygen. Similarly, another two orbital in the another oxygen, because of oxygen plus oxygen. Now we will see carefully, my dear students. This is the pz orbital. This is also pz orbital. So this pz orbital, this pz orbital end is this pz orbital end is. So end on end overlapping of the pz orbital. Most important point, in oxygen molecule, what orbitals are involved in the end on end overlapping? pz orbital. So one oxygen of pz orbital, another oxygen of pz orbital, end on end overlapping to form sigma bond. So now this one pz orbital lana. This one pz orbital, another pz orbital, end on end overlapping, sigma bond is formed. Understood? Sigma bond is formed. So one orbital is completely involved in the bonding, that is a pz orbital. That pz orbital to form the sigma bond. But py orbital. This is the py orbital. This py orbital. Here ends are not there. Side. This is one side. This is one side. So side on side overlapping. Py orbital. Side on side overlapping. Now sigma bond is formed. So see here, two dot lines, two horizontal line is sigma bond. See, here not mentioned sigma bond, but lines are draw because of this is the sigma bond. This is also considered as a sigma bond. That's why in oxygen molecule, my dear students, in oxygen molecule, one sigma bond, one pi bond is there. But my dear students, this is also pi bond. Not mention, don't write here one more pi bond. This completely py orbital to show only one bond, that is called pi bond. Understood, Aicha? So in oxygen molecule, two bonds are formed. One is a sigma bond, one more is a pi bond. So this is the most important two terms. One is a sigma bond, another one is a pi bond. But pi bond is a weak bond. But comparing to strong bond, comparing to sigma bond is independent bond, but pi bond is not independent. What is the reason? Initially sigma bond is formed, later pi bond is formed. That's why pi bonds is not independent bond, sigma bond only independent. Why it's called sigma bond only independent? If some of the molecule form single bond, that is independent, only one bond. Sigma bond only is present in the single bond. So that's why sigma bond is a single bonds, and sigma bond is a very strong bond, and sigma bond is a independent bond. So if the pi bond form after sigma bond formed, pi bonds are formed. So this is the ரொம்ப important statement தம்பி, sigma bond and pi bond. So what is the sigma bond? Once again I repeated, end on and overlapping of the orbital to form sigma bond, it is represented like this symbol. And pi bond, side on side way overlapping of the orbital to form pi bond, it's represented by mathematical sign, mathematical symbol pi. So pi na side on side overlapping. So the best example is a O2 molecule. In case of triple bonds lo enna aichi, oru sigma bond, two pi bonds is there, or sigma bond, two pi bond. The best example is a nitrogen molecule. Okay na? Now this is the sigma bond and pi bond. Now valency, important word in valency. This word is frequently coming in the chemistry. Valency. What is the valency? The combining capacity of an atom. Listen carefully. The combining capacity of an atom with number of hydrogen atoms or number of chlorine atoms or double number of oxygen atoms is known as the valency. So don't forget, my dear student, most of the students should follow the combining capacity of an atom is called valency. But the full-fledged information enna, the combining capacity of atom with number of hydrogen and or number of chlorine or double number of oxygen atom is known as the valency. For example, this is ammonia molecule, ammonia NH3 molecule. Right now my question is the combining capacity. Which one is combining capacity? Nitrogen combined with hydrogen. So already I said here the combining capacity of an atom with number of hydrogen. So in the now I am asking question is nitrogen valency. So opposite to hydrogen is there. How many hydrogens are there? 3 hydrogens are there. That's why the valency of nitrogen is 3, because of already told number of hydrogen atoms or number of chlorine atom, but or double number of the oxygen atom. Double number of the oxygen atom. Now see here carbon dioxide. So carbon dioxide na 2 oxygens is there, double number. So 2 oxygen na double number enna aichi 4 aichi. So here most important the 4 aichi. Oxygen, each one is 2 nana. Number of chlorine atom, double number of oxygen atom. So double number means 2 2s are 4. So here carbon valency is the 4. Valency of carbon is 4. Here valency of nitrogen is the 3. Next one Cl2O7. Here chlorine 7. 7 2s are 14. 14 means each chlorine carry 7. So this is the valency. Romba important definitions, my dear students. What is the valency? The combining capacity of an atom with number of hydrogen or number of chlorine or double number of the oxygen atoms is known as the valency. Next one, Already ionic bond characteristics also already completed, and covalent bond category, types of covalent bond, single bond, double bond and triple bond also completed, but overlapping is also completed, sigma bond is also completed, and pi bond is also completed. Now the important part is characteristics of covalent bond. If any one of the molecule showing covalent bond, what type of the characteristics are there? So the important and 4 marks question point of view, characteristics of covalent bonds are very, very important. So first point in the characteristics of covalent bond, non-metals only involved in the covalent bond. That is the most important point ma. Non-metals only involved in the covalent bond, and mutual sharing of electron in between of the two atoms. So this is a basic point. First point is the non-metals only involved in the covalent bond, and second one is the mutual sharing of the two electrons, mutual sharing of the two electrons from two different atoms. That is called two important key points of covalent bond. So remaining characteristics, see, these compounds are molecular form in the nature. For example, if you take any one of the covalent bond, definitely it will show molecular form. It's not a atomic form. Always is molecular form. For example, HCl. HCl is a molecular. Cl2. Even different atoms combined together, also molecule. Same atom also combined together, also molecule. For example, Cl2, Br2, I2, F2. These are all are the molecular form of the covalent bond. Because of Cl2 na, chlorine to chlorine single bond is there. So similarly HCl, HBr, HF. That's why my dear students, generally the covalent bonds are generally in molecular form existed in the nature. So first one, these compounds are molecular forms in a nature. Molecular forms in a nature. Second one, covalent bonds are generally weak bonds. It's not a strong bond, but exceptional cases are there. For example, graphite to diamond. Diamond is a very strong bond, but generally covalent bonds are weak bond. Second one is a important point. Third one, some covalent bonds existed liquid state and also gas state. So, but some covalent molecules are generally existed solid state. The best example is, for example, liquid state. What is a liquid state? Best example is a water molecule. Water molecule can be existed in the liquid state, but here covalent bonds are there. Similarly, gaseous state. Gases, hydrogen molecule is a gaseous, and even chlorine gases also there. But some of the covalent bonds are existed solid. The best examples are diamond and graphite. So mostly covalent bonds are, covalent molecules are generally existed in the liquid state and also gaseous state, but a few one are existed in the solid state. The best examples is diamond and graphite. Next, fifth point, it has low melting point. MP means melting point, BP means boiling point. It has low melting point and boiling point due to the weak attraction forces, in between of the two atoms. And sixth one, important point, low melting point and low boiling point. And sixth one, covalent compounds are bad conductor of electricity except graphite. Generally, all covalent compounds are bad conductor of electricity, but graphite is a good conductor of electricity because free flow electrons are present in the graphite. That is the reason it is act as a good conductor of electricity. But it is a covalent compound, but it is act as a good conductor because of the free electron flow. Free flow electrons are present in the graphite atom to another graphite to graphite. Next, seventh one, covalent compounds are show structural and space isomerism. This is a very important point ma. Covalent compounds are show structural and space isomerism. So already I teach this area isomerism in 11th standard. So sorry ma, this is not coming in our coming chapters. Organic chemistry I will teach isomerism. Already in 12th standard students already learned this concept. So covalent compounds are show structural and space isomerism. And eighth point is non-polar compounds, non-polar covalent compounds always soluble in the non-polar solvent. Already you know that very well, non-polar covalent compound and polar covalent compound. What is a non-polar covalent compound? Non-polar covalent compound na the same electronegativity elements involved in the covalent bond, that kind of the molecules are non-polar covalent bond. It's nothing but it's a not form any type of the poles. For example, H2 molecule, Cl2 molecule, Br2 molecule, I2 molecule. Here H2H, hydrogen to hydrogen, same electronegativity. So same electronegativity atoms involved in the covalent bond, the sharing of electrons are very equal, not a abnormal. It's equal sharing. Equal sharing, no, poles are not formed. That's why non-polar covalent compound always soluble in the non-polar solvent. So example, non-polar solvent example, CCl4, CS2, benzene, carbon tetrachloride, carbon disulfide benzene. Keep it in your mind, my dear student. If any one of the non-polar covalent bond is there, na, this is soluble in the non-polar solvent. Non-polar solvent na CCl4, CS2, C6H6. Next, polar covalent compounds are soluble in the polar solvent. The best example, H2O, CHCl3, alcohol, etc. So these are the most important characteristics of the covalent bond. Now, coordinated covalent bond. So I successfully completed still now ionic bond, characteristics of ionic bond and properties of ionic bond, how to form ionic bond, and covalent bond, overlapping, and sigma bond, pi bond, characteristics of covalent bond. So another one, so unstable element, to get a stable configuration, they are following three different type of bonds. One is ionic bond, already explained, covalent bond also explained. Now coordinated covalent bond or dative bond, it's the most important, Nana. Coordinate covalent bond and dative bond. So see here, in case of ionic bond, Nana, listen very carefully. In case of ionic bond, one atom completely donated one electron to another atom, hence to form the ionic bond. But in covalent bond point of view, two atoms are approaching to each other, they are mutually sharing their electrons and to form bond, that is called covalent bond. But in coordinated covalent bond, romba important thambi, coordinated covalent bond, two atoms are approaching to each other, one atom completely donated one lone pair of electron to another atom. So second atom, there is no any electron, but it has empty orbital. So in coordinate covalent bond, once again I repeated, in ionic bond, one atom completely transfer of one electron only to other atom, hence to form ionic bond. Covalent bond, not transfer of electron, but mutual sharing of the electrons, then bond is formed, that is called covalent bond. But coordinated covalent bond, when two atoms are involved in the coordinate covalent bond, one atom's completely donated one lone pair of electron to second atom, but the second atom always containing empty orbital. So this kind of the bond is called coordinated covalent bond. In coordinated covalent bond, one atom completely donated one lone pair of electron, it's a donor, and another atom accepted the lone pair of electron, it's an acceptor, but it has unpaired, it has a empty orbital. Ipo empty orbital irukana, first atom easily to donated the lone pair of electron. So that is the coordinated covalent bond. You know, coordinated covalent bond represented arrow mark like this one see, Nana. So now see what is the definition of coordinate covalent bond. This type of a bond, one atom donated to one lone pair of electron to the other atom, the lone pair of electron shared between the two atoms. So or A atom donated one lone pair of electron to the B, but ultimately this A and B shared that lone pair of electron, equally share the lone pair of electron. A only donated lone pair of electron to the B. See now this is a lone pair of electron, this lone pair of electron donated to the B, so in between dative bond is formed. So the lone pair of electron shared between two atoms, but ultimately the two electrons are belonging to A, but in the sharing point of view, two atoms are sharing. So once again, coordinated covalent bond means if two atoms are involved in the coordinated covalent bond, one atom is completely donated one lone pair of electron to another atom, but another atom is always contain the empty orbital, but this electron pair shared between the two atoms. Okay, ma? Now it is represented by arrow mark. One note. What is the note? In this bond, one atom should be completely octet configuration. A completely have octet configuration and extra lone pair of electron is there. So that's why this extra already A is complete octet configuration. So why A is donated lone pair of electron? Already it is to satisfy the configuration. So that's why extra lone pair of electron donated to the B. So now see here, in this bond, one atom should be completed octet configuration, but have at least one lone pair of electron, but other atom should have a deficiency of electron, at least one pair of electron, but it's containing empty orbital. So first atom octet rule is there, first A atom completely satisfied with octet rule, but extra lone pair of electron is there. That extra lone pair of electron donated to another atom, but another atom deficiency of electron, but empty orbital is there. Now see, X is the lone pair of electron, Y is the empty orbital, so coordinate covalent bond is formed. Now in this bond, provided electron pair sharing of atoms is called donors, accepted electron pairs is called acceptor. So the best example of coordinate covalent bonds is ammonium ion NH4 plus and hydronium ion H3O plus and ammonia boron trifluoride and N2O and ozone. These are all the. So now in this class I draw only one structure. In my next class remaining structures also I can draw it. So now ammonia molecule. Now see here, ammonium ion how to form? NH3, nitrogen has one lone pair of electron plus deficiency of one hydrogen. NH4 completely means one hydrogen is deficiency, ammonia is one lone pair of electron. This lone pair of electron donated to this hydrogen, NH4 plus is formed. Now see here, NH3 lone pair of electron, hydrogen has empty orbital, this lone pair of electron donated to here, this bond is represented, the yellow color line is represented dative bond. You know that dating means boy and girls are dating na, boy is always spend money to the girl. Okay, in one case. Another case, boys and girl is always spend money to the A. So that's why this bond name is the dative bond. Okay, Nana? So now here, nitrogen, 3 hydrogens are there, and this one, this dative bond, listen very carefully, this dative bond sharing two atoms, nitrogen atom and hydrogen atom, but electrons are belonging to the nitrogen. Okay, Nana? So in my next class, remaining examples I will teach. Okay, na? So this is a dative bond.